So this was I want to kind of preface everything by saying that this is a world that's moving incredibly fast. This is a version of a talk I gave last summer, and I basically had to redo big parts of it because the world has changed dramatically around us, even since last summer. So this is kind of my best guess today where we're at. It's clear that there is a seismic impact of LLM tools on our industry. I think anybody who tries to tell you they know exactly what's going to happen is probably trying to sell you something and probably is, not correct. But, I think there are some principles and there are some interesting things to think about. And so I want to discuss that. I'm going to have the chat open. I have a talk prepared, but if people have questions or want to stop, I would be more than happy to have questions throughout the talk. Don't feel like you have to wait till the very end if you have something you want to discuss or you want to bring up. So I want to just introduce myself a little bit. My name is Michael Hilton. I'm a teaching professor at Carnegie Mellon University. I've specialized in software engineering. So this picture of me is when I used to work for the Department of Defense. I was a software engineer, and I did a project at the White House Situation Room that then President Obama said was cool. So that was pretty exciting for me. That was kind of the pinnacle of my maybe professional software engineering career. I will say I did not get a medal from the president for doing software engineering, which Mary Shaw did. So I've a long way to go to catch up with the illustrious Mary Shaw, but she's absolutely fantastic, and I'm really proud to be associated with her. But the other thing I want to kind of point out here is that I'm very proud of the fact that I have one extra degree than most of my colleagues, which is my first degree there in Associates of Science, which means I started at community college. So I'm very proud of that. I think community colleges are a fantastic thing in our country, and if anybody else has been around a community college, I think it's great, and I'm really glad but I've been at CMU for eight years now. I did my Ph.D. at Oregon State, and as I said, I worked as a software engineer for SPAWAR at the time it was called. Now it's called NavWarSen or something, and I was there for almost a decade as a software engineer for the Department of Defense. So yeah, this is that article. It's called "You're a Computer Science Major, Don't Panic." So if you know anything about op-eds, we did not write the headline. The headline is written by the editors, not by the authors of the paper. But this is the article written by me and Mary Shaw. You can go read it online if you want to. I think I'm pretty proud of how it came out, and I think that I think it makes some important points. And even though we didn't write the headline, I agree with it, and I think it's a good headline, right? I think that there is large scale changes, but I don't think we should be panicking. And I think we have a history of software engineering. As a software engineer, someone who's practiced software engineering, who now has a PhD in software engineering, who teaches software engineering classes. This is my main area, so this talk is going to be more software engineering focused than computer science focused, because that's my area, and more education focused than business or anything else focused, because that's my area. But I think that it's not a time to panic. I think it's a time to be thoughtful and to be careful, and to be excited, but I don't think it's a time for panic. So my main kind of my role is a teaching faculty. I'm a teaching professor, not a research professor at Carnegie Mellon. And so I really focus a lot on pedagogy and education. And I think people talk a lot about AI and education. But one thing that really I think is important is that there are two real big questions, I think, here that are separate questions that we need to engage in. And one is, how should we teach, which is how do we effectively deliver software engineering and education in a world where Gen AI exists? I think Gen AI has dramatically disrupted our pedagogical techniques. The things that we used to do in the classroom just a few years ago don't work the same. How we think about learning is different because there's different tools with different affordances that we didn't have in the past. And then on the other hand, we need to think about, what should we teach? How do we think about educating students for a career in software engineering in a world where Gen AI exists, right? So one is, how do we teach people as students, acknowledging the fact that AI is a real thing? And the other question is, like, what should be our goal? Where are these students going to end up? And I'll be perfectly upfront with you that I think I have some really strong principles for how we should teach. What we should teach is much more speculative, and I'll give you a few opinions that I have, but I think this is more, I think how we should teach is about applying principles that are tried and true. And I think what we should teach is a bit more speculative and involves a bit of predicting the future, which humans are notoriously bad at. So we'll get to we're going to start with thinking about teaching and education in the world of AI, and then we'll spend a little time on what's the world going to look like. But that's going to be more speculative, and I'm open to discussing that. But how can we effectively teach or learn software engineering in a world where Gen AI exists? This is the big question I want to start with, right? So I think this is an important topic for both educators and the general everyone, because everyone should be, even if we're an educator, even if we're a professor, we should still be always learning. And I think that one thing that's really important is to never stagnate and never stop learning things. So I always try to read, new books. My daughter's teaching me how to knit. I'm not good at it, but I think it's good to learn new things, right? And I think it's good to find a shared hobby to spend time with your kids and stuff like that. But I also think it's good to put yourself in a position where you are a learner and not a teacher. It helps remember what it was like to not know something, right? So many of us have been doing software engineering for quite some time, and it's hard to remember what it was like for us when we didn't know computer science, software engineering. And so, by learning new things, this can help keep us fresh, keep us a little bit humble, but also, how we want to do that effectively. How can we do that effectively? Both the teaching and the learning part. So this is a great quote from Herb Simon. He's one of the someone from CMU that you probably have heard of. He won a Turing Award and a Nobel Prize of Economics. He said, "Learning results from what the student does and thinks, and only from what the student does and thinks. The teacher can advance learning only by influencing what the student does to learn." Right? And so I love this quote. One of my degrees is from Cal Poly San Luis Obispo. I got my master's from there. This is also where both my parents are alumni of Cal Poly San Luis Obispo. And their motto of the model there of Cal Poly is learn by doing. Right? And I think that this kind of principle of learn by doing is something that Simon is advocating here, right? Like, students learn by doing and thinking things, right? Not from watching things, not from hearing things, not from seeing things. So I can give a fantastic lecture, but if the students just kind of sit there listening and I'm just talking, they're not going to learn nearly as much as if they're doing something, if they're being active, if they're engaging. In fact, this is partially why I invite questions throughout the talk. If it helps to be more interactive and you're more engaged and you're thinking and doing more things with asking questions, you'll learn more. We'll learn more. It'll all be a better experience for everyone, right? So, but this is kind of my guiding star here. I'm going to talk about how we break this down into some specific principles. So here's the principle. I think the world is changing dramatically. What AI capacities are changes every day. It seems like every hour by hour, probably. I put these slides together this morning. Probably by tonight, things are different than they were this morning, right? But I think there are some enduring principles that aren't changing as quickly as the tools are changing, right? So AI will result in learning when it influences students to do or think. So I think a great benchmark to think, am I going to learn through this process? Is to think, am I doing and thinking things in this process? And if you're offloading the doing and the thinking to a tool, you're not going to learn. And if you are using the tool to help you do more doing and more thinking, then you're going to learn better, right? So there's a huge difference between someone asking the AI to write their homework for them versus someone who doesn't understand something in a part of a homework and using AI to investigate how a certain language construct works, or what are some good templates for a code review, or something like that, right? So, we were talking about a code review example before the meeting started, right? And an experience I had with a student recently. If a student just asks the agent to do the code review for them, they're going to learn basically nothing, right? But if the student, asks the agent what makes a good code review, does the code review, maybe runs it through an agent, says, critique this code review, right? This is involving more doing and more thinking. And so the students will be learning, right? So this talk is not necessarily pro AI, and it's not necessarily anti AI. It's pro humans and pro learning. And I think LLM tools and AI tools can be powerful tools to help learning, but they also can, unfortunately, and sometimes result in shortcutting people's learnings, which leaving them without learning. And I think this is a real problem, right? And so, I think many of you probably have seen things like this anecdotally, but there is some data out there on how students are using AI, and it's not great always. So not quite a year ago, Anthropic released this education report, how university students are using Claude. So this essentially, they're looking at interactions between people with .edu addresses and Claude. This is an official Anthropic report, so this was vetted by the lawyers and everything. And if you look at here, this is directly from the report. You can see that direct problem solving and direct output creation accounts for almost half of all of the requests in almost every discipline. So that means for most, then they also have this category of collaborative problem solving and collaborative output creation. So it's from, half of the queries the students are asking, they're just saying, give me the answer. And they're not trying to work through and solve the problem. They just want an answer, right? And so I think that's concerning if half, and then if people are just getting answers, they're not going to be doing and thinking, and they're not going to be learning. So there's a question here in the chat, so I'm going to pause for a second and read that and answer it. What do you think of students using agents as substitute dev teammates for learning, i.e. agents as project manager, QA, etc.? I mean, again, I think this boils down to if the student's doing or thinking more things, right? So if they're offloading everything to the agents and just spinning up the agents and walking off and then coming back hoping that everything is done, I think they're not going to work well, right? I think if you ask the agent, be the project manager, and now I want to have a conversation with you, and they practice conversations, or they, they are committing code, but they're doing their part and they're trying to do teamwork, I think they can be very powerful tools for that, right? It is a little tricky because as of right now, many of the tools seem to be optimized for giving answers more than for working with people. But yeah, I love this analogy of taking a forklift to the gym, right? Clearly, this is maybe a bit of a tangent, but I think it's important, right? I mean, one thing people will ask me is are you worried about computers being more powerful than humans, right? This is a question that I get a lot is when people find out I'm a computer science professor. And I always say absolutely not. I mean, if you think of what is the most basic definition of a machine, right? If you think back to physics, right? A lever is the most simplest. A simple machine, type 1, is a lever, essentially, right? And so ever since the first human used a lever to move a rock they couldn't move otherwise, machines have been more powerful than humans, right? And so, is there power? Yes, obviously cars are a lot faster than humans, but I still ride my bike because it's good for me to ride the bike, not because I think the bike is going to beat the car, right? Same thing with the forklift to the gym. In college, I worked in a warehouse and I drove a forklift, and it could definitely lift a whole lot more than I could lift, right? But if I'm trying to get stronger, I need to be doing the lifting myself, not offloading that to the forklift. Again, the principle of I'm doing it is helping me, and having a machine do it for me isn't helping me get any stronger, smarter, etc. So just to kind of keep on this task, finish up the thing from the report here, right? We see that a big part of of what people are asking for is just creating, right? Which is, in Bloom's taxonomy, we need to do all these other things, and we need to, these kind of low order thinking skills are really important. And historically, it is the case that, you had to work through all these steps to get to the creating stage, but now we can use these machines to shortcut and skip things like understanding, applying, and analyzing, evaluating, and jump straight to just a creation phase, right? Okay, some of these questions are good, but I'm gonna not pause. Some of these I'm gonna get to later. So I think let's keep going, and then we'll come back to them later if we have some time. Okay. One thing I want to say, though, is that I think students are understanding this as well. So we did a survey in my class last semester. So this was the fall of 25. And we got 100 responses. We asked students, has AI helped your learning? Do you think AI has been a net positive on your learning experience? And you can see here where 5 is the best and 1 is the worst, that they're generally positive, right? That the majority of students said, weakly agreed that it is a good thing for their learning. The thing that I found fascinating is we asked them a separate question, which was slightly different. And that question was, has AI helped your peers learning? And if you look at the second graph, you'll see that the distribution is shifted pretty strongly to the left, meaning worse, right? So students generally are very positive about the AI as being a net positive on their learning, but they're much less positive about AI being a net positive on their peers' learning. So there's a sense that, generally speaking, people think it's helping me, but it's not helping everyone else nearly as much. So, this is just student perceptions. This is not actual data of actual learning, but I think there's some really interesting things here, right? That maybe people judge other people's learning a little bit different than they judge their own, or maybe things that feel good are easier to evaluate in other people if it's being a negative. Or maybe there's a few people who are very negatively affected, and everyone recognizes that, and put that there. There are unfortunately also some research papers that have come out that show kind of similar effect, that for professionals that are using Gen AI, there's a reduction of cognitive effort and confidence from knowledge workers. So, this work is all still early on. It's still ongoing. Some of this is maybe, all the studies here were done pre-agentic AI. So, things are changing rapidly. I'm not saying the tools will always be like this. I think we also are in this stage where there has not been the culture around what is appropriate uses and not appropriate uses for students. And so I think as the world progresses, maybe we'll find better ways to use this technology to be more helpful for people's learning. But there's a challenge. And so one of the things that's really important in education is this idea of component skills. And so when you take on a high complexity task, this is not something that if you're going to cook a delicious 5-course meal, right? You don't go from not cooking anything to cooking a delicious 5-course meal, right? You got to learn the individual parts. You got to learn how to cut up the food. You got to learn how to saute the vegetables. You got to learn how to cook the pasta appropriately. You got to learn how to, season the meat properly or whatever, all the parts of it, right? But each of those is a component skill, and then you bring it together and you synthesize it into, making the delicious meal, right? And so it's really important for students to develop mastery. Students need to be able to develop mastery, and to do that, they have to acquire the component skills, practice both the component skills and integrating them, and know to apply when they have learned. And this is something that's covered in this book, How Learning Works. It's a research-based principles. It's a great book if you're at all interested. I highly recommend it. So, for students to achieve mastery within a domain, whether narrowly or broadly conceived, they need to develop a set of key component skills, practice them to where they can be combined fluently and used with a fair degree of automaticity, and know when and where to apply them appropriately, right? So you have to acquire the component skills, and you have to integrate them together, and you have to know when to use which skill where, and that is how you achieve mastery, right? And maybe one kind of popular culture example of this, right, is this, for those of you who are approximately in my age group will remember this movie, right? And this whole idea of like wax on and wax off, right? So Daniel is trying to become a karate master, and Mr. Miyagi forces him to kind of wax the car and sand the fence and do all these menial tasks. And then it comes out later that what he actually was learning was the individual component skills that he was going to use to, win the great karate fight, right? And so, but these component skills, he's waxing like this, and what he's really doing is building up the muscle memory and learning this action, right? And I think this is a really nice way to think about this. We don't just jump straight into the karate match, but you got to learn all these little component skills, right? And some examples of kind of technical component skills, and there's been research on this, right? And some examples of these were like, so consider like writing a linked list, for example, right? So there's component skills of syntax, there's component skills about abstraction of pointers, there's component skills of abstract reasoning about data structures. If you're anything like me, there's probably debugging component skills involved in this, right? Maybe how do you run the program is maybe a component skill, like actually like compiling and running, right? These or interpreting and running, depending on which language you're talking about, right? But this is a problem, right? Because in the real world, we don't need a bunch more kind of poorly written introductory linked lists, right? Like we have plenty of linked lists in the world as it is. And, LLMs have made the cost of getting a linked list to be essentially zero. But the problem with this is the point of these students, all these students writing linked lists around the country, is to develop these component skills that then they're going to use later on. And my concern is that if used poorly, Gen AI can shortcut the development of the component skills, which will lead to people never achieving mastery, which I think is a problem. And I have some data here in a few slides I want to show you that I think the students are also worried about this. So I think this is a real concern. And this doesn't mean that Gen AI is always bad, but it means certain uses of it will, I believe, can shortcut these building of these component skills, because the Gen AI tools are very, very good at doing things like the component skills, right? Looping, writing a for loop, writing a short linked list, right? Basically anything that you do in an intro to computer science class to build up the component skills are essentially solved problems for LLMs at this point. And so this is, but the point is we need to think about is if LLMs exist, how can we think about building up these component skills? What are we going to do to help people get these component skills? And so one analogy here is this idea of a calculator. A lot of people think about, I've heard many people compare LLMs to calculators and say things like, well, we have calculators, so this LLM is kind of like the calculator for code, right? And so, but at the same time, I would say, like, for my son who's, 9, I have a son that's 9 and a son that's 10, that's 11, right? The 9-year-old is doing his math completely without calculators. The 11-year-old is starting to adopt a calculator. The point is not that they're great at that the 9-year-old doesn't think calculators exist, but we want him to learn these component skills of basic math facts, being able to do addition and multiplication in his head before he starts to combine those, right? And so, LLMs can program faster than a human. LLMs, similar to the way a calculator can do math faster than a human. But again, it kind of goes back to the forklift analogy. Is the point to lift something heavy to do a big calculation, or is the point to learn these component skills that then you can use to do larger calculations? And then another question is that I'm concerned about is calculators are always right? We don't need to teach people to evaluate the output of the calculator. We can just assume the calculator is correct. And I don't, that's still absolutely not the case for LLMs. Now, they're very good at doing a lot of things, and they often come with very good solutions, but they're definitely not always correct. Even today, I was doing some vibe programming, and it was wrong a couple times on different things, and I had to pull it back and do other things, right? Like this is the paid tier, Opus 4.6. I'm a paid Claude user, right? It still gets things wrong, right? And the calculator essentially never gets things wrong. So there's still, for who knows how long, maybe different people have different opinions. So we can talk about the future later. But for now, at least, there's still this need to evaluate the output, which is not something that calculators have. But, I don't know. So I think maybe a different analogy is, compilers. I know that compilers are, it can be wrong, but I never have found a bug that it was the compiler's fault and not my fault. So in my experience, compilers are always correct. I don't know. I think maybe more of a power tool is a better use, right? The power tools enable you to do more faster, but they also can do things poorly if you don't use them correctly, right? And so a human can use a power tool to do things that they couldn't do otherwise, but you can't just, the power tool isn't building the house. The power tool is a tool to be used by the human. Yes, indeed. The calculator is weirdly AI generated. I am using this as a meta point that we do still need to correct. We still need to check AIs, and sometimes they're not always right. So I will talk about that later. I will use this picture again later, but someone caught on to my setup of my joke. But yes, great catch there. Okay. I want to talk a little bit about this, though, and talk about why this is hard and why we as learners need to be careful, and why we need to be, I think there is a temptation to be like, well, kids these days, I learned to do all this by hand, and they should learn it too, and kind of to be, to have an attitude that is maybe not understanding of the challenges that people face, right? And one thing that I really want to discuss on this slide is this idea that when we ask people to learn, or when we're trying to learn, we are moving across the spectrum. So you start out in anything in unconscious incompetence. So as an example, I met someone recently who lives in Bulgaria. They were Americans, but they live in Bulgaria. I speak not a single word of Bulgarian. I learned through this conversation they use the Cyrillic alphabet. I could not tell you a single word in Bulgarian. Right now, I have unconscious incompetence for the Bulgarian language. Now, if I went to Bulgaria and tried to speak to people and realized that I couldn't speak to them, I would move into the conscious incompetent. I would start to know what I don't know, right? Right now, I don't know what I don't know, but the first step in learning is learning that you don't know and moving into conscious incompetence. Then you slowly move into conscious competence. And then eventually you arrive at unconscious competence, right? Right now I'm speaking to you and I'm not thinking about English grammar or the construction of English sentences. I'm unconsciously competent in English. And I actually speak Spanish quite well. I lived in Spain for a while growing up, and I speak Spanish at a level of unconscious competence mostly, where I can just speak it, right? But I think it's the one thing is really important here is that we understand that unconscious incompetence to conscious incompetence is a painful step. And we're asking people to come face to face with the reality that they don't know something and have to grapple with something that they didn't know it existed, and now they know what they don't know, and they are now feeling the effects of not knowing it. And conscious incompetence is a much more painful place to be than unconscious incompetence. And so when we are asking people to learn, we're asking people to move through the pain of unconscious incompetence, through the pain of conscious incompetence, into competence. And so I think that's really important. Yes, this is from the book How Learning Works. I have it down here on the slide. I'll make my slides available afterwards. But it's a fantastic book. I definitely recommend it. So the point here is to say we need to keep in mind that we're asking someone to do something challenging and something that is hard. And also we need to, if we're trying to learn on our own, it's going to be hard. And so having LLMs that give out answers for free is really challenging, especially when you're in this kind of the emotional valley of conscious incompetence. It's very tempting to just get the answer for free and not kind of work through your conscious incompetence. And that's just more of that's just a big challenge. Okay, so how do we motivate students to persevere in component skill learning? Because it is hard and it is a challenge. How do we do that? So I will say before LLMs existed, we often motivated people with extrinsic motivation, things like grade. And honestly, it was more difficult to find the answer oftentimes than it was to just answer the question, just to do the homework, right? Or easier to detect, right? We had code cheating detected software that worked pretty well overall before LLMs existed, right? But honestly, I think the path of least resistance was mostly just to do the work, right? It was kind of the easiest path was to do the work. But after LLMs, right, correct answers are available with little to no effort. LLM answers are impossible to detect with high confidence, right? And so the easiest path forward is not doing the work, right? It's just getting the answer from the LLM. And I'm not saying this to say like impugn their character or to call students cheaters who are using LLMs. That's not at all my goal here. But I do want to point out that we're now asking everyone to kind of, this is one way I've like to think about this is like, I don't know if you've heard of the marshmallow experiment. It's this idea where if you put kids in a room with a marshmallow and if you tell them don't eat the marshmallow, you can, and you come back, I'll give you 2 marshmallows or something. The students who have the kids who have the self-control or auto-regulation or whatever you want to call it, to not eat the marshmallow, delayed gratification, end up being much more successful in life. There are some problems with this. I'm not saying that all the science behind the marshmallow experiment is totally solid, but I think the principle holds, right? That there's value in life to being able to do something that's hard, even if the easier thing is not as good for you, right? It's important to eat your vegetables, even though dessert tastes better. And now we are kind of engaging in this marshmallow experiment where our education needs to grapple with the fact that students now not only do they have to do the work, they have to understand these difficult technical topics, but they also have to kind of go through this emotional valley of conscious incompetence, but they also have to now have the self-control, determination, whatever you want to call it, to not get the answers when they're free, especially for these component skills. And that's really, really tricky. I think the testing of students, I want to address this real quick before we move on. There's a lot of interesting questions here about how do we assess, right? So I'm not talking specifically about assessment here. I'm talking about motivation, but assessment is a really interesting question. One thing that we're doing in one of my classes this semester is we are moving to an LLM-based oral exam and trying to get the students to do an oral exam that's administered by an LLM that gives feedback immediately, but we also are going to be human grading it. So we can possibly talk about that afterwards. I think it's a really interesting. I think LLMs open up new, interesting avenues for understanding as well. And I will say that students, know this. We asked the students again. This was that survey we ran earlier, and I asked students what their concerns were, and almost 90% of the students we surveyed said that their main concerns were over reliance on the AI and a shallow understanding, right? And so students are concerned about the fact that I think at this point, students are coming to understand that if you just ask the LLM to do everything for you, you will not learn, and at some point this will be a problem for you. And I'm very happy that my students are understanding this and understanding that shallow understanding, over reliance is a concern, and I think they're right to be concerned. I don't think they should, be. I don't think it's a problem that can't be overcome, but it's a good problem to be aware of at least. So this is something my dad always says, and I really like it, so I'm going to quote him. People don't care how much you know until they know how much you care, right? I think we have to understand that everything's changing. Things are difficult for students right now, and we need to get students to care. But I think this has always been the question, right? The good teaching always was about getting people to care. So I think we need to be explicit. Like, why do component skills matter? We need to explain to the students that we want them to be masters of their craft, and we want to give them the component skills, and we need them to develop those component skills. We want to tie those high-level skills to long-term goals, right? We want to provide authentic tasks when possible. And we need to identify and reward what you actually value, right? Think about, what are our learning objectives? What do we really want students to learn? What do we really need students to do? I think oftentimes classes have been, there have been things that we just do kind of historically that make it, that are not really assessing the real skill we want. They're just assessing a proxy that has often been considered good enough. And maybe we should be thoughtful about, are we really assessing proxies, or are we assessing what we actually know? And if we can only assess a proxy, is our assessment of the proxy good? Is it, how true is it to what we actually care about? I also think we need to be careful, right? What if we're causing the students to do or think the wrong thing, right? We don't want to cement bad habits when we are teaching students, right? This is something we should be very careful about. So this is an older experiment now. I mean, the tools have changed dramatically, but I did an experiment a couple years ago in class. And one thing that really struck with me was that students' proficiency seemed to highly correlate with demographic groups and things that we would call, like, oftentimes we would consider different groups to be higher or lower self-efficacy. And I think that this is, and I had a student who was a great student. She ended up being a top 3 student in the class. She got a bad answer from the AI, and she tried to follow the incorrect direction 6 times in a row. And then when I asked her what was going wrong, she said, I can't figure it out. I'm not sure what I'm doing, right? So she kind of ascribe the problem to herself when in fact it was the AI just gave her the wrong answer, right? Meanwhile, another student who was male said programming with an AI is like yelling at a stupid person, right? And so he didn't at all feel this sense that like it was his fault. This is kind of maybe a crass way to say prompt engineering, but he felt like he was superior to the AI and he was going to just keep yelling at it until it got it right. Versus the other person asked once when they got a bad answer, then they didn't. They just kind of assumed that artificial intelligence was the right thing, right, and didn't want to push back on it. And so this is, I think as these LLMs get better, this almost becomes a bigger challenge, right? And how do we help students understand, when to push back on an LLM, when to have the confidence to do that? How do we help people's, who have low self-efficacy raise their self-efficacy, raise their actual efficacy? Right? These are all like really important questions to me. And so, one thing I've done as a follow-up experiment is now whenever we talk about Gen AI, we make a really big deal of pointing out that these tools occasionally give wrong answers. And as people are kind of being more acclimated with it, students are seeing the, hallucinations and bad answers as well. And I try to anecdotally demonstrate this. I try to show them examples of bad answers. And I try to be explicit that when things go wrong, it's not the user's fault, that these tools just do the wrong thing, and you have to assess it, analyze it, be thoughtful about using the output or not, but you as the human need to make that decision, right? And I, by demonstrating this, it seems to really help people understand that it's not on them, and this also helps as we develop kind of cultural understanding of how these tools work and understand. Another anti-pattern that I've seen a lot is what I call slot machine programming. So last semester, I had a student come in after a challenging homework and come to office hours, and she obviously was hadn't slept well and was kind of very kind of harried looking, and she said she's been working like really hard on this homework, and I believed her. She looked like she was kind of spent a lot on it. And then I asked her, well, what have you done? Walk me through kind of because she couldn't get it to work. I can't get it to work. I was like, okay, well, what have you done? And her literal answer was, well, I tried Claude, I tried ChatGPT, and I tried Gemini, and none of the answers are working for me, right? And so this is not an academic integrity violation for our class. That is totally okay. But she was doing what I like to call the kind of slot machine programming, right? She just keeps stochastically asking the same question to different LLMs, getting slightly different answers, plugging them in, and just hoping that one of them will work, right? But people, when they're doing this, are not necessarily building a mental model and progressing towards a goal. They're just essentially playing a slot machine where you just keep hitting that generate button, hoping that you'll get 3 cherries coming up, but not kind of understanding what you're doing or developing a model that in your mind that is helping you move closer. And so one thing that's really an open question for me is how do we instill this kind of judgment in our students to help them understand kind of how, if they're moving forward or not. I think these are really going to be the deep questions we're going to wrestle with in the few years. Because if programming is essentially free now and code is essentially free, that doesn't mean that engineering decisions or the process decisions are free or can be made by these tools. And so it's something that we need to think carefully about. Okay. We've done some vibe coding exercises in classes. I'm not going to go through all this in detail. I'll leave some of the slides there. I think that these are some feedback from students last semester. Some of the students said they're going to be more cautious about using AI. Some students said they're going to be using AI more than before, right? So I think there's a wide range of usages. I think there's also this point that I don't want to drain my wallet with 1 billion subscriptions, that these tools are not free and not all students have the same access to financial resources. And I think that's something that maybe sometimes gets a bit overlooked. And I think it's still something to be thinking about, right? So I don't know. I don't have a good answer for that specific point yet, but I think it's something to be thinking about. So why does it matter what students think about the AI tools? I just want to kind of quickly say that attribution really matters. So one thing that we can really do for students is help them understand that their mistakes are not about whether they belong or not. And students who feel like they belong will attribute the mistakes to the inherent challenge of the task. And I guess one concern I have is that there's a lot of messaging out there that says that these tools are going to solve programming, or programming is going to be easy. Anybody can program anything now. And I don't think that's necessarily true yet. The tools are incredibly powerful and they can do amazing things, but I think students still need to understand that the tools can still go wrong. You can still use the tools in the wrong way. You can still generate bad code, bad designs, and these are still really challenging tasks. And when something goes wrong, you shouldn't just immediately think that you don't belong or you're not a good student. You should understand that it is challenging, and you're going to have to work through these challenges to get there. So this is another great book, The ABCs of How We Learn. It talks a lot about changing attribution. It talks about, there's some studies that happened in 2011 that showed that this was really helpful for students who felt like they didn't belong in college, to, if you could reframe their interaction with college and help them understand that they belong, then they had much, much better outcomes. And so one thing that I think is really important in these tools is that we don't frame kind of a tool hiccup or a tool not being used properly as someone doesn't belong, isn't the right kind of person to be a programmer or something like that, right? So it's something to be thoughtful. I feel like I have been a bit negative about Gen AI up till now. I do want to point out some positive things that I think are quite interesting and quite useful, right? I want to go back to this idea that I talked about, that students need to do and think things. And if we can do that, the learning outcomes will be improved. So I have some friends that I'm working with at the University of Sevilla, and they are working on a tool that does requirements engineering with Gen AI. And so what happens is, before Gen AI, we used to do interviews in our software engineering class, but we ended up cutting them because students would need to interview humans. There was a high human cost to the time of the subjects. The course staff didn't have visibility into what was happening during the interviews. The subjects would often be overly agreeable, didn't really know what they needed, talk around in circles, and that sort of things. And so what they're doing is they're using Gen AI to help create personas which people can use to practice interviews with. And so students can practice interviews with Gen AI before they go out and interview humans. And students are generally bad at interviews, in my experience. And so being able to practice and getting feedback directly from the tool, I think really is showing promise at really helping students, right? The course staff has the transcript of the interview. They can review it. They can give feedback. They can have visibility in what the students are doing. This is low cost, so students can repeat these interviews until they achieve mastery. And Gen AI characteristics match the human subject tendencies. Humans tend to be overly agreeable, don't know what they're talking about, talking in circles. And it's very easy to get Gen AI to be overly agreeable, not necessarily know exactly about what it's talking about, and talk in circles. And so, so the way this works is that the students actually interview a Gen AI agent, which is, they just can do a voice interview, and there's a scenario, it's like a ticketing system for theater, and you're interviewing a theater manager and the prompt kind of explains a bunch of the context, and the students have to ask a bunch of questions to figure out what is the software that needs to be built. So, I mean, this is a use of AI, but it's helping the students do and think more things. They get more practice doing interviews. They can do orders of magnitude more interviews than they could have done when we had to rely on finding people to go talk to them. They can get immediate feedback, targeted feedback, which is another key of learning, right? So I don't think that this should replace all human interviews, but it can serve as a simulator. It can help the students practice at scale and build up these skills in a way that they weren't able to do otherwise. So I don't know. I think this in general, I think this idea of using Gen AI to provide opportunities for students to practice and do things that they wouldn't have that we don't have the capacity or the bandwidth to create these many opportunities without Gen AI is a really positive way to think about Gen AI in education. I honestly agree. I think they would build stronger skills by practicing with a real human being, but I think this can get them up to the point where the interviews with the humans provide more value because they've built up at least some skills before they get to the human. So this is more kind of like the idea of a driving simulator to help you learn how to drive before you go out on the road. It's not to say that you never go out on the road, but if you can build up your skills in a simulator before you head out on the road, the transition will be easier and it'll be easier to achieve mastery. Okay, now I'm going to keep going on. Yes, exactly. That's kind of like giving speeches in front of the mirror, right? But you don't get feedback in general when you give it in front of the mirror, right? Maybe your friends can give you feedback, but same thing. Okay. How should we think about educating students for a career in software engineering in a world where Gen AI exists? So this is the more speculative part of the lecture. I expect more disagreement here, perhaps, or just I think there's a lot more uncertainty here. So I feel pretty confident about the stuff I've set up till now. This I'm going to say is I feel less confident about, but I'm going to say a couple things. I think it's interesting, and then we can move to a discussion time. Right? So, will software engineering exist in 10 years? Some people are saying no. Right? There's definitely a lot of people who are very smart that I respect think that, either it's going to go away or there's going to be dramatically less software engineers. I also want to point out, a different perspective, right? So there's this idea of Jevons paradox. So Jevon is this economist in England in the 1800s, something like that. And he was particularly looking at coal, but what he described has been seen in many different places. And his paradox describes a situation where technological advancements that improve the efficiency of a resource use actually lead to increased overall consumption. So this occurs because efficiency gains make the resource cheaper, which in turn stimulates increased demand and usage. So the idea is that he was specifically looking at coal. Coal used to be very expensive and people didn't use it at all. It became much more efficient to make coal. And you would expect the usage to go down, but in fact, it went up because it was so much cheaper. They used it for many, many other things, right? So if gas suddenly went to right now our cars run at 30 miles, whatever, my car runs at 20 miles a gallon or something like that, right? If a car could run at 200 miles a gallon, maybe I would just leave it on running overnight so that it's not frozen in the morning, right? And I would change my behavioral patterns. I might end up actually using more. Maybe as a society, we might end up using more gas because we're just driving everywhere and doing stuff that we wouldn't need otherwise, right? This is kind of like a well-known conundrum especially in ecological sciences, where a lot of this stuff is making things more efficient for the sake of making things better. Sometimes it leads to actually more usage. So I think there's another perspective that's maybe in 10 years everyone will be a software developer, right? Maybe every dentist office is going to have custom built software, and every real estate agent and every pizza restaurant and that there'll be all this software everywhere. And so maybe everyone's going to be doing software development or software engineering even in 10 years because it's so efficient and so cheap and easy to make source code, right? And so I think there's at least as good a chance that that we have way more software engineers in 10 years than that software engineering goes away. The other thing I want to point out is just to remind people, hopefully most of you are aware of this, right? That most developers spend, this is pre-AI, most developers spent about much less than an hour coding a day. There's all sorts of different estimates and stuff. Some people, I've seen that some number that people write 11 lines of code per day on average, according to one study, right? But this is not the majority of what a software engineer's day-to-day job is not typing out code, right? And so software engineering is a lot more than programming. So, agents are getting there, agents are doing a lot, but there's still a lot that goes into building deployable software that's not coding, right? And so I think at this point, writing code is basically solved. It's essentially cheap and essentially free, but there's a lot that goes into software engineering that is more than just coding, right? And I don't know, this has really come home for me. I have a friend of mine who I mentioned I lived in Spain earlier, and he wants this app for this radio station. It essentially has this pause play button, and there's a couple buttons to share some links. A very, very simple app. And I decided I was going to only help him with this, and but I was only going to use LLMs to do it. I wasn't going to write the code myself because I knew I could write the code myself, but I wanted this to be a learning experience for me. So I tried the kind of naive prompting strategy where I just kept throwing prompts at it, telling it what I wanted to do, and it just kept failing over and over and over again. And so then eventually I took a step back and I said, okay, well, let's try to guide the LLM as if it was a student, which is how do I work with students. So it's like, okay, that's too big of a step. What's the smallest first step you could make? Okay, let's try that. How do we know it's working? What can we come up with a test to test it? And I kind of step through with the LLM the same way I would step through with a student. And it's worked quite well. And I've developed a bunch of features for it recently using that kind of very step, breaking down the problem, using my software engineering expertise, getting it to write the code, but then also running tests, evaluating the code, testing it myself, checking to make things are working, stepping back when things don't work. And it's a lot of like 2 steps forward, 1 step back. And so, it's in my experience, I think we're still definitely in a world where we're going to need a lot of software engineering skills and abilities, even if the code is being almost completely written by LLMs. And so I think you see a lot of like CEOs out there saying, 80% of our code is written by LLMs, or we expect 100% of our code to be written by LLMs. And I think, okay, maybe your code is all written by LLMs, but that doesn't mean all the software engineering is being done by the LLMs, right? We're definitely not at the place where we can just not do the software engineering work, even if a large amounts of code are getting written by LLMs. But the $1 million question is something that Lisa put here in the chat, and I want to just be super clear, right? So are the component skills of coding still necessary? I think that's the $1 billion, $1 trillion question, whatever you want to say. I think that it's not clear. I think they are personally. I know people who I respect deeply who disagree with me on that. How do you evaluate if the tool is working properly if you can't even read the output, right? This is a really, really big and important question. And maybe someday we'll get to the point where we can trust the code to always be right and we can consider it as a level of abstraction. I don't go in and read the assembly language when I run code through GCC. I am fully trust that GCC can compile the code correctly. I don't ever double check GCC, but I still double check the LLM, right? And so maybe someday we'll get to a place where there's GCC level of trust and we move up the layer of abstraction, but we're not there yet. And I think we're a ways from being there. And so how do we build those component skills when they aren't really quote unquote needed in the job, but the knowledge of them and the mastery is used for more complicated tasks is absolutely the right question to be thinking about and asking, and is really, really important. So where do we go from here? I'm going to go ahead and wrap up here pretty soon, and then there's a bunch of interesting things that we can keep talking about. But I think we should rethink software engineering education a little bit, right? So some of these ideas came out in this New York Times article we referred to at the beginning, right? Should we teach reading before writing, right? So my 11-year-old can write a like half of a page paper, but can read Harry Potter, right? For humans, when in teaching, natural language reading and writing, we expect students to read vast amount of material relative to what we expect them to do in terms of writing, right? But for CS, we very rarely teach people how to write, how to read code. It's almost always just something that gets picked up along the way after we teach them how to write code. And in fact, after I wrote that New York Times article, obviously a bunch of my friends saw it because it was in the New York Times, and we're talking about it. And I had a friend who I know socially who is a librarian at Pitt, and he has a Ph.D. in some sort of English or something like that, some sort of a humanities Ph.D. And now he works in the library at the University of Pittsburgh. And he kind of was a bit dismissive and combative of the article, which kind of surprised me because he's a very nice fellow. And I was, and we started talking. He's like, well, this article doesn't, it's kind of like pointless. And why are you talking about this? And what are you saying this? And it kind of surprised me, actually. And then we talked around in circles for a little while. And at some point it dawned on me and I said, so do you think that, because we advocate for teaching students how to read code and that you should do that, maybe even before they start writing code. And I'm like, well, do you think we teach students how to read code, systemically in computer science? He's like, well, obviously, how could you possibly learn to write something if you've never read it? And I'm like, see, there's the point. There's the misunderstanding that you have with the article. We don't teach people how to read code. This is not something that gets regularly taught. And it blew his mind, and he couldn't imagine a world where we're teaching people to write something without, teaching them how to read or evaluate it, right? And so I think this is something that we've long focused our education on writing, and to the detriment of reading and evaluating. And it's something that we need to think about maybe changing, right? Is this idea of judging an AI a separate skill, right? Like, you prompt it and it gives you a response, and you have to decide if that response is good or not. Is that the same skills we've always had? Is that a new skill? I don't know, but I think it's something to think about, right? What are the skills students need to be able to do software engineering in a world where code writing is free? This is that question that Lisa said earlier about, like, is the component skills of coding still necessary? I personally think it is. But it's, I don't know. How long is it going to be relevant? Is it going to be forever? Is it going to be, in 10 years, maybe it's not as relevant anymore? Lots of programs don't teach assembly language anymore, but at one point that was the only way to program, right? So I do think it is possible to imagine a world in which writing code isn't something every student learns up front. But I definitely don't think we're there yet, and who knows how long it'll take us to get there, right? Harlan Mills did do this. That is true. There have been some, I would say that these are the exceptions that prove the rule. There have been some very amazing people who have done the reading first, but that, I would say, is generally the exception if you look at all of the students who learn programming or CS across the whole country. So when I say we teach reading before writing, I mean that as a generalized statement, not that there aren't specific luminaries who haven't done that in the past, because Harlan Mills was well known for doing that and doing it quite well. How do we teach students validation and verification for code that they didn't write, right? Historically, validation and verification have kind of happened in situ while the code was getting written, and then testing is usually an afterthought for students. But if code is being generated, do students have the skills to validate and verify that the code is right, especially code that they didn't write, right? So I think this is a really important question and something that we need to think about. So, I'll leave you with, I do think with some of these LLM tools, right? This is the famous Pittsburgher Jeff Goldblum in Jurassic Park, right? He says, the scientists were so preoccupied with whether or not they could, they never stopped to think about if they should. And I think there are parts of education where there are things that tools can do, but maybe we still need people to do them to build up their skills. And just because we can build a tool that can do something doesn't mean that's not what's most helpful for people's education. So I'm going to finish with my statement, kind of my semi-provocative manifesto-like statement. I think software engineering should be about people building software for people, and they should use tools to do that and use the tools as best as possible. But ultimately, I want to advocate for we're building the software for people. The people are the ones building the software, and so I want to make sure we don't lose the human focus aspect of software engineering. So, thank you for listening to the talk. I know we've addressed some of the questions along the way. There was stuff in the chat that I didn't have time to address. I appreciate all the attention. I've seen a lot of the things go by, which I think that people are definitely engaged, which I think is great. So I have some time if people would like to have a discussion or ask some questions. I want to address one thing before I finish. Bill said, learn by doing means writing things first. I think that's has absolutely been true for a long time. I think the question is, what is doing if doing doesn't mean writing? So if I'm not writing code as part of my software engineering job, then maybe I need to learn by doing, but what I need to be learned by doing is judging the output of the LLM more. I think this is what some people would say. I'm not sure if that's true or not. It's unclear to me. So anyway, thank you for your attention. Thank you for engaging. And I'm happy to chat for a little bit or ask questions in the chat, or I don't know how you normally handle this, Dennis, so I'll pass it back to you. But yeah.
All right, thank you. No, we'll we can people can unmute and ask questions. Raise your hand. We'll get through as many questions as we can. But we'll do 15, 20 minutes and call it quits because I know you're tired and I'm tired and it's like we're all getting through. Anybody have something to start with here? Because if you don't, I have one. One of the things that bothers me with AI generated code is that applications in the real world often live longer than just, I'm creating some trading software that I'm going to use for 2 weeks and then throw it away and build a new application. Things will last for months or years, and you'll add features to them. The problem with adding features is if you have the AI regenerate the software, maybe all the menus will move, and you will violate the principle of least surprise for usability. What do you think about that?
Yeah, I think that the as of right now, it is clear that the one of the things the tools don't do well is context, right? So on a shorter scale, one thing I've noticed a lot with students having trouble when they come into office hours is they'll try to do something that the tool can't do, and it'll give them a bad answer. Then they'll say that didn't work, try again, and it'll try answer B, which is also bad. And then they'll say that didn't work, try again, and they'll go back to answer A, and they'll keep ping ponging back and forth between A and B. Every time they say it doesn't work, try something different. It will just invert from A to B, but it's not actually moving forward. It doesn't have a mental model of what is going wrong and how to move forward from it, right? And that's on a super small scale of like one small tiny thing. It definitely doesn't have that over the course of like how is this software going to live? How are we going to maintain this? My good friend Hiram Wright, who used to work at Google, wrote the book Software Engineering at Google, which is a fantastic book. He talks a lot about how we should think about software differently based on the longevity of the software, right? So if we're writing a little script that we're going to throw away, we don't really need software engineering for that. We just need to code it up quickly and then use the script and then move on to the next thing. But if we're going to write some piece of software that our business is going to be using for 20 years, we really want to think carefully about the software engineering principles behind, documenting the change and thinking carefully about, what are the long-term effects and, think about all these principles about information hiding and all this sort of stuff, right? And so I agree with you. I think that there's a big difference between maintaining long-running software systems and just writing a piece of code, right? And this is why I think that the people who think that software engineering there's a big difference between programming or writing some code and doing software engineering and maintaining a software over time. Principle of least surprise. All these things are really principles of software engineering, not about code writing. And the tools are great at code writing, but they're really not great at software engineering as of today. And I don't think we'll be in the anytime into the future, short, medium term future.
Okay, let's call on Josephine here. You got your hand up. Josephine, you can unmute yourself.
Can you hear me now?
Yep.
Yes.
Thank you. I really enjoyed this presentation. Um, I still have a lot of apprehension around the use of generative AI, and I really don't see the point of using it if it's going to generate anomalies and novelty and hallucinations that then whatever it generates is going to have to be reviewed and checked because of the possibility of um, irrational information, inaccurate information being generated. And I just wondered if you might comment on that in general.
Yeah, I think that a lot of this depends on what like I think there are I think it's impossible to make broad assertions about all code and its relationship to Gen AI, right? So for example, I certainly hope the next time I get on an airplane that they haven't vibe coded the control software for the airplane, right? I think we all could agree on that. That is not a good place for vibe coding, right? On the other hand, if, you know, my kid wants a game and I can like throw something together in an hour that lets him play tic-tac-toe and it, he finds it amusing, what are the implications of this not working? It's not that big of a deal, right? And, I think there's going to be an age of I think that large software engineering projects for heavyweight industrial like important software is still going to keep going much the way it has gone for a while. But I think there will be a explosion of kind of small personalized. I have a friend and he was just telling me that he vibe coded an app to help his friends he really likes the band Goose and they tour and he's with this group of people that they like follow this band around and go to the concerts, right? And so he created a social networking app for the people who follow the band around to use to contact each other and meet up and stuff. And there's like 50 total people for customer base for this app that he vibe coded, right? And it wouldn't have been worth it for him to do it, handwrite it, but also like if it doesn't work amazing, like it's him and his buddies, they're probably all texting anyways, right? So I think there's things it's really good at, like CSS, for example. I spent 10 years writing CSS professionally as part of being a full stack developer. I can't write CSS and like trace it like you do like program tracing, or like I can't write the CSS and imagine what the screen is going to look like. I still guess and check when I write CSS. I write CSS, then I make a little change, reload it, and try to do that because it's not like it's a declarative language. It's all visual, and so like these tools are really really good about take that button and move it to the right and stuff like that. So for like CSS, it's really great. For heavyweight algorithms, it's not. So I think a lot of this depends on what is the ramification if the code is wrong. How much do we really care if this code is right or not? I think there's a lot of code that doesn't have to be right 100% of the time and just has to be kind of good enough. And I think for that, then AI can be good enough for good enough. But
I guess my concern is that I'm thinking about your unconscious competence and so forth. There are people out there who don't know that they don't know, and there are safety issues involved. And when you take something, maybe benign in one context, and you attempt to do something, even coding or something else, in a different context, there's that law of unintended consequences that kicks in sometimes with pretty disastrous consequence. And that's just one of my concerns about generative AI. We won't talk about the environmental concerns or the ethical concerns and like that.
Yeah, I think you're absolutely right to have that concern, and I think we absolutely will see things go south or go poorly for people who aren't thinking. I mean, I think security vulnerabilities are going to be everywhere. I think that there's going to be a lot of impact of this, and I think you're correct in your assessment that there are going to be problems with people not knowing what they don't know. Absolutely.
Thank you.
All right, let's go with Bob. Hi, Bob. You can unmute. There you go.
Can you hear me?
Yeah, now we
Yes, we can.
Okay. For a comment to Josephine. Josephine, I think the problem is worse than what you are fearing. There's a paper that I went in one of my classes, Write No Matter Why. It's also about human-computer interaction. When people were interacting with computers, they had more willingness to believe what was false than interacting with a human being, and they were more willing to change their opinion more quickly than with a human being. With the greatest problem I fear with generative AI is it's an amplifier for misinformation. And we have a universe of people who are unbelievably gullible and are swaying their opinions way more than they should. We have a lack of critical thinking that is an epidemic going through our country. And so that's the comment to Josephine is we need to educate people about how to think more critically at a very much earlier age. The comment for Michael is I had a student last semester who was working on a script, and she said it was running forever. And I took a look at her script, and she had two loops, so it was an order n squared operation that she was doing. Now, if n was small, it's okay, but in this case, n was a million. She should have had enough background as a graduate student in computer science to know that order n squared when n is large is not good. One of the best things I've ever seen in computer science is the film Sorting Out Sorts. It makes something visual in a really clear way. It's one of my favorite things. We should have students, train students, to look at examining bad code. This is something that's wrong. What's wrong with this? Why is this not working? And have some analysis that they can get some understanding so that they can trust the output.
Yeah, I totally agree. I think this is that thing that I feel like I've been, I totally agree that there's this, it kind of works, and you kind of keep going until you don't realize that it's, n squared for a million is going to be a bad thing, and I think that they're absolutely that these tools can lull people into a false sense of security. Again, I will point out, as the software engineer in me will point out, that code was correct. Let's say this code was vibe coded. I have no idea what the context is, but assuming a hypothetical where a student comes in and they have code that's running super slow because it's a poor algorithm, it still is correct if that's what they asked for, right? The code, it's the judgment to understand that nested for loops are going to be slow here. That doesn't mean the code is syntactically wrong or that it wouldn't run given some other much smaller n, right? And so to me, this is this issue of like judgment that we need to be teaching that's different than this idea of coding. So just the syntax.
This was not something that was generated by a large language model. It was something that I had given her the framework for, and she misunderstood how to do things. And she didn't understand when she should use hash tables versus explicit lists. Some basic data structures that would have made the big difference. And this was a person who was working on the master's degree in computer science. I was expecting something better.
I'm just saying, I think I realize that in this instance it wasn't an LLM, but this is a specific case of a general case that happens all the time with LLMs, where someone gets given code they don't totally understand, and they don't have the judgment skills to look at it and say, oh, this is going to be a problem for my specific context or what I'm trying to do. And so that teaching those judgment skills, in this case, they got it from you, another human, but millions of people are getting code from LLMs all over the world today, and then they have to look at it and make a judgment about it, and people aren't necessarily have those skills to make good judgments, and I think that's a real problem.
Yep.
Exactly. Thank you.
You have the same problem if you're picking something out of open source.
Yeah.
Yeah. Let's get a question from Bill. Hi, Bill. You can unmute.
I think the students majoring don't really have to worry about it. In my world, working on a big computer system where there's a big need for analytics and report writing and getting data from databases, most of the people in my company, well, I think I'm the only one here now who actually writes reports and knows what a database is and does all of that. And so the LLMs, when they finally appear here, are only going to help me work faster. A lot of the coding has been moved to India, and so if anything, things are going to keep expanding, and there's going to be more of a need. And even with LLMs, I don't think the humans will be able to keep up with the demands. When people need reports from a business system for real information. They need validation and they need intelligence looking at it. So your students are safe, Michael Hilton.
I actually also believe that. I guess I'm much more concerned about, quite honestly, I'm much more concerned about executives buying into the hype and firing people because they think they don't need them than them actually not needing them. But perception is reality, and executives thinking something dumb and making poor decisions based on a dumb thing is not something that would be new to our country and something that I'm generally concerned about.
I think people are getting fired because the executives are overpaying for data centers, not for any other reason.
I think that is, yes, making decisions based on something dumb will continue. I agree with Josephine on that one.
All right, Andre, you got your hand up.
Yes, thank you. The points I wanted to make tie in with some of what some of the other people said, even though I put them in the chat earlier. I'm really concerned about people being able to evaluate the code that's generated by LLM or whatever other tool they happen to be using. I'm concerned that if they don't code themselves, they won't be able to distinguish between verbose code, efficient code, inefficient code, code that's insecure, code that has lousy performance characteristics. I'm a performance engineer, by the way. And I'm wondering how we can make sure that the students are going to think about these things when they're using code that's been generated automatically.
I mean, I think this is the $1 million question, right? Like, I think this is the really important thing, right? Like, how do we do that? Historically, the way we have done that pre-LLMs was we generally had them write a bunch of code and would critique the code, and through the writing of the code they learned these things, right? Like, is the code efficient and that sort of things, right? Is that still what's going to be the way to forward? It's not clear to me, right? Like, the students need to be doing that. So is it that they need to be writing a bunch of code? Is it theoretically possible that they could learn to evaluate the efficiency of code without writing a bunch of code themselves? I think that's theoretically possible. Will it actually work in practice? As a much bigger question, right? And in theory, there's no difference between practice and theory. In practice, there's a huge difference between practice and theory, right? So theoretically, I think, if the point is that you just gave a big list of really important skills for students to have, or professionals to have, and I guess what I'm arguing is that I totally agree. Those are really important skills. Historically, we have taught those skills mostly through code writing was the primary mechanism we used to teach most of those skills. Now, code writing is free and when you ask students to write code, many of them are going to do something that doesn't involve them thinking or doing, but involves them copying and pasting. And so I can guarantee the ones who are copying and pasting are not going to learn that list of important skills you listed. Is there other ways to teach those skills directly where we show them a bunch of pieces of code and they have to read the code and make decisions about whether the code is efficient or not? Is it, I think as an educator, it's exciting to me to think about what are the ways we can think about, changing our pedagogy. With one nice thing about LLMs is that we can generate lots and lots of examples really, really cheaply, right? And so historically, one of the reasons why we didn't teach through showing hundreds of examples is because we didn't have the time or the ability to generate hundreds of examples, right? Now we can. And so maybe there are other ways to teach things besides coding, besides the students doing the coding is a question that I have. But that would be unproven, and we would need to figure out how to do that.
Could we generate test cases of different sizes automatically and require the students to run those test cases with a start and stop timer and also with profiling so they can see where the system is spending its time?
Yeah, I could imagine a world where we did that and the students are actually learning profiling as the skill they're learning, right? And they're not necessarily writing code to learn profiling as a skill.
We actually do something like that at Stevens
Yeah, I mean, I think
in
that
our
sounds
testing course.
I mean, that sounds fantastic.
All right. I got one more question from Joe. Go right ahead, Joe.
Thanks. Great presentation. I've got a comment and a question. The comment is that it's striking to me that so many claims are being made about what LLMs are capable of and what they're going to be doing, that they're going to remake the whole economy. Yet we don't have anything like some kind of reasonable, semi-formal math or similar process to show that's the case. We don't actually know or have good reason to show how far these things can go in organizing intellectual work of any sort. So why is that? And why are these assumptions being made? And given that, don't we really just not know right now how far LLMs can go in organizing a large code base? Thanks.
Yeah, I think. I think I mentioned this earlier. I think anyone who tells you they know how things are going to play out is, selling you something or is just dangerously wrong, right? I agree. I think we don't know how things are going. I think it is fair to say that LLM tools, as of today, are dramatically different than things that came before. In 2005, when I was working, as a full-time software engineer, I didn't have any tool that could do the types of things that the current LLM tooling can do. So they are different than things we have seen in the past. But this whole predicting where things are going to go is very difficult. Humans are notoriously bad at predicting the future, right? One thing I think about a lot is, a lot of times technology, when it comes, there's this phenomenon with technology that when it initially launches, there's a lot of easy wins that make it much more efficient or much better early on, but then it reaches kind of a steady state. And kind of we see this over and over again, right? And so, even just thinking about like cars, for example, right? If you look at the first Model T cars, right? They didn't have a top. They look wildly different than today's cars. And if you go through the like 1890s through 1930s, the cars are evolving very rapidly and drastic changes are happening to the cars. But then you look at a car from the 50s or the 60s and you squint and you look at a car from today and it doesn't look that different. And I know there's been some changes, but there's a lot less change between a car from 1955 and today than there is between a car from 1955 and 1905, right? And because there's a basically one shape that make more cup holders today. Okay, that is true. So we do have more cup holders, but there's essentially an aerodynamic shape, and all cars eventually kind of reach a mean there, right? Because they're trying to make them efficient, right? And original cars had one brake pedal for each wheel. We quickly learned that was a horrible idea. We want one brake pedal for both wheels, right? And so there's just things that people learn and move on. And so I wonder, I think a lot of the predictions are kind of assuming the same amount of exponential growth or in capacities or capabilities for these tools, but that's not what we see in most technologies. I mean, I have a phone here, right, that is much like most of the phones probably you all have, and these things, the first couple iterations of smartphones kind of drastically evolved, and now whenever I buy a new phone, I can't even remember what number phone I have, and they don't really change that much, right? And so it's true. Cars are constrained by physics and not with software. So that is true, and that could be different. But, I don't know. Again, predictions are hard to make. I totally agree. No one really knows what's going to happen. I do think that LLM technology, is based on kind of this idea of stochastically predicting the next token. And I know there's more to it than that, but that's kind of the foundation of LLMs. And I think I personally believe there are limitations to what we can do in terms of like judgment and reasoning about, is this the right problem? Is this the right software? Are we thinking carefully about what the software requirements are there's limitations to how far you can get with predicting the next token in that direction. I think it's an average answer, right? That's another good point, right? So if you want to like code to open a file in Python, the average answer is probably right. And so just using the average answer to correctly open a file in Python syntactically is probably the right thing to do and easy and fast. But deciding what to do for profiling or something like that is not necessarily something that there is an average answer for.
All right. I have one extra question I want to slip in there, and it was something that was asked right near the beginning. They say, why haven't we had Donald Knuth's Art of Computer Programming rewritten by AI yet?
So is it written by AI or rewritten for AI? I think those are maybe two different questions.
I think it was rewritten by AI. Let me check.
Okay. Yeah, so I see it. Why hasn't AI written an improver? I mean, this is my personal opinion, is the AI isn't going to write an improved, like AI is not going to take leaps forward. It's going to give you, I agree with the person here, Jim, who said that it's an average, right? And so it can give you the average answer. And for some things, averages are great. The wisdom of the crowds, right? There's this article in the New York Times where they asked people to guess the weight of a cow, and they asked like 10,000 people, and the average of everyone was quite accurate, even though individual answers were often off by a lot, right? And so there are certain questions for which an average answer is good, right? But Knuth's book wasn't the average. Knuth wasn't the average person writing the average book, right? And so I think the next Art of Programming or whatever is not going to come out of something that's just giving average answers. And I think asking a tool that's developed to give you the average answer is really good for some things and really bad for things like moving the field forward like Knuth did.
Yay. All right. This was a fascinating discussion. I hope you had as much fun as we did.
I had a great fun. Thank you for inviting me. I'm glad that I can do this virtually, and I get to go back and sleep in my own bed tonight, but also have a great time with you all and wherever you are all.
Yeah. All right.